Yeah, so we're going to do a bit of method review, and then we're going to talk about how we can replace our rectangle with some images. So what is a method? It's a function that belongs to a class. So what makes it unique is when you create an object of the class, you can call the function from that object, and you can also have that function access like different attributes of the object. So if you have like the symbol function in this case, which is like you create a method in a person class and you want to return the age of any person, then you use the getAge function on them. But maybe you want, like, in a game scenario, you might come up with more complex methods, like, oh, when I press the space key, I want to like shoot a bullet. Then you would have like a shoot function, and then it would work for all of your each instance, each player instance that you create. So it's like easy to reuse. And also, once again, the self keyword is, first of all, it has to be the first parameter, and also you need to use it whenever you want to reference the, you use it in a method whenever you want to reference the object of the class. All right, that's probably confusing. But basically, the example is probably the easier way to see it. So you create like some object, maybe you create like a snake object in the snake class. Then if you want to, what is it? Whenever you use the self keyword, so maybe you say like self.length or whatever, if you have, let's go back here. So I guess in this case, you have self.birth here, which the self keyword is like a placeholder for the object that actually calls the function, right? So at first we're like, the SAM person hasn't been defined, so you just kind of use self as a placeholder, but then once you create the SAM person, you can assign it to, you can create an instance of the person class called Sam, and now like when you say sam.getAge, you kind of think of it as you pass this Sam here right into getAge as the self parameter, so it's like, who am I calling it on? There. So, whoops, did I not edit this? There you go. So I guess the easiest way to think of it is if it's called sam.getAge, I'm literally copying and pasting the object itself and replacing the self keyword with it. So that's kind of how it works, right? What else? This is kind of just an extension of like the self keyword. Like, yes, you can access variables, but you can also access the ball's own their own methods as well.
You stopped sharing the screen.
No. Oh, that's sad. Yeah, so here I just copied and pasted. I said like if you want to use the way to think of self is like when you call any method with an object, and kind of think of it as like pasting whatever the object is in, and you're like, okay, this is the person's birth year that I want to get. Okay, and then you can also call. It's kind of like how you can call functions within other functions. So if you want to move diagonally, you want to move to the right, and you also want to move this down or up. I think it'd be down. Wait, no. I think it's up. Shoot, I forget. I forget which way the coordinate. No, it would be down. But anyways, that's not really, it's not super relevant. But yeah, you move on the horizontal axis and the vertical axis, and then you can move at the same time. You go diagonal. So it's kind of just an example of that. And of course, you need to pass the self keyword if you want to be able to call like the method, right? So you have like square dot move x. What is it? You know, honestly, the easier way is like you should just always include the self keyword. It's good to have, because yeah, you'll avoid bugs that way. But I rarely see like functions in a class where they don't have the self keyword, because otherwise, like, why are you making it a function? Just like make it like, sorry, not a method, just like make it a function on its own, right? So quick question: how many times is self missing from this class? Yeah. Also, I recommend trying to do it without the multiple choice, and then once you kind of think you know the answer, you can check the options. That's like the fun way to do it. Actually, it's still pretty tricky anyways, but. Also, Jahan, when you get the results, can you screen share them? Okay. Oh. Um, let's see. I have to share again. Yeah, so I'm just gonna kind of type them in. init function, obviously you need self keyword because okay. Just thinking here. Okay. So here you need the self keyword. Okay. I'm actually pretty sure. Okay. So I'm pretty sure this byte function here needs the self keyword as well as. Okay. Damn, it's confusing. But anyways, I'll try my best to explain. Okay, I might. You guys will have to double check this on me, but I'm pretty sure most functions will. Actually, no, that's not. It's not that relevant. The self. Okay, I will tell you the init function definitely expects the self keyword because if you, that's the first argument it will expect. So if you don't pass the self keyword, it won't. It would just be like, oh, fruit name is like what you want to call it, right? So this definitely expects the self keyword, and so you need self to like if you want to initiate the object. How do you set the attributes of the object without the self keyword? So I guess these are probably the obvious ones, right? So you got those two, and then we have here if you want to be able to call this as a method. So if you want to be able to be like, I don't know, then you need the self keyword, but also you need the self keyword before the byte function. Otherwise, if we're not using this, then you're saying like there's some random function that's like defined byte here, which I mean, technically, I suppose, but given this context, you can see it right underneath. So the intention is to call this byte function, right? And so we have 1, 2, 3, 4, 5, and the last one is just this self keyword. And this is the one that I'm like, so I'm pretty sure the reason that you need it is so that you can actually call it as a method from here. So that's why you need the self keyword here, even though you're not like explicitly saying like, you know, self dot bleh. So that's the reasoning. I will have to check that. Sorry, guys. But yeah, I would say just assume that it's because if you don't have the self keyword here, you won't be able to access it from your other classes. So that's the most likely reason. Actually, maybe one of the mentors can like check that for me. Okay. So, but yeah, I would say like to be safe, whenever you have a class, the easiest thing to do is always put self as your first thing so you just don't forget it. Because if you do pass in a parameter, the first one, it always assumes that's a self keyword. So, okay. So next thing we're going to do is what's Pygame sprite? It's literally just like, sprites are like, what's the best way? Yeah, any object on the screen that uses an image when it's drawn. Okay, that's actually the perfect definition. And there's also other things that Pygame can do, like you can add like sounds and what else can you do? Oh. Okay, so the sprite class has some built-ins. I'm actually pretty sure that you do not need a sprite to do sound. Definitely images and animations. That's what the sprite class has to do with it. Behaviors is not really specific to the sprite class. It's just that you can like when you use the sprite class, you'll be able to add things to something called a group, which makes them easier to draw and easier to update them together. So I would say like the main things for the actual sprite class is really just like this stuff over here. So you have, it expects you to have an image and you want to have a rectangle. So the rectangle is for collision detection and also just tracking where your sprite is actually on the screen, and your image, well, that's what you want to display. And then you have your two methods, which are the draw and the update. And so draw is like, it's a built-in and basically makes it easier to draw onto the screen. It just draws it for you instead of you having to be like, oh, pygame.sprite.blit at the location of the rectangle. It just does that automatically. And finally, your update, you define it. It's actually like, it is built into the sprite class, but by default, there's nothing in there. But you're like, okay, I want you to check for like collisions before you, and update the position accordingly before you draw it. And so that's what you put in the updates. And sound and behaviors is like code. You code that in. But sound is just something. There's other Pygame stuff you can do sound with, and I'm quite confident that it's not specific to the sprite class. So I'm just gonna remove to avoid confusion. Okay. So basically everything's a sprite except for the backgrounds. It's kind of how it works. It doesn't have to have collisions. Like, yes, you can make it have collisions, but that doesn't, you don't have to have collisions to make it a sprite. I would say like anything that's an image on the screen is a sprite. So you could consider like the background as sprite as well if you really wanted. So, but that's, details aren't really that relevant. Usually for the backgrounds, what I would do instead of making like specifically a sprite class, because I don't need collisions for the background, I would just put like, I would use, there's some built-ins for Pygame where you just draw. It's like I would draw a big rectangle on the screen. Like I wouldn't, because it never changes, right? So also, there's some like useful stuff you can do with sprites. There's one thing, so here's an example of the, whoopsie. You have your Pygame, you have a class that inherits from Pygame sprite class, which means it inherits these two properties here. You have your, it'll expect an image in a rectangle and also expect draw and update methods. And then, what else? Yes, so if you inherit from the Pygame sprite.sprite, it'll expect an image and it'll expect a rectangle so that it knows where to draw the rectangle. That's what it does. You also always want to initialize the stuff in the parent class. I actually don't know exactly what goes on, but there is stuff to initialize, so do it. And then we talk about image.getRect. This is it's a useful function that gets you like a rectangle in the size of the image. So if you're like, I don't know what the dimensions of my images are, it's like a very nice flexible option. So you can set your rectangle to the image. Finally, you have your update and you have your, okay, sure. You have your update method, which is like if you define, if you inherit from pygame.sprite.sprite, so Pygame's built-in sprite class, then you can define this update method. And if you do define the update method, there is a way to call it efficiently. You'll see. There's a way to call it from what's called a group, which is, it's really equivalent to having a list and looping through the list and like calling the update method on each object in the list, but Pygame has a slightly faster way of doing it. So that's why you might define the update method. And here's just like a class that belongs to the fairy. So maybe you would be like, let's call, self.move 5 or something. I don't know. And finally, let's go on. What else? If you want to use the fairy image to follow along, you can go into the slide. The image is, let me send it. Oh, there's stuff in the chat. Okay, thanks for confirming, Fatal. That's the image. And so, okay, there's actually like kind of an important detail about file pathing, and I should probably demonstrate now. Here, 1 second. I need to open up VS Code. It's so slow. You know what? Fine. I'll demonstrate the file pathing. Yeah, I'll demonstrate the file pathing thing after the quick question so I can load it up. But first of all, the way you get images is you download the image and you put it in the same folder as your code, right? Or if you want to be organized, you would make an assets folder and you would put the image in there. And now you have the way you load your image is there's something called, okay, first of all, you don't actually need this OS module. It's just good for like working with paths because maybe you're using Windows or using Mac and like the pathing is slightly different, like the forward slashes and backslashes. So that's why it's good to use OS to ensure your string looks correct. So os.path.join literally just turns this into like, I'm assuming you're on Windows, right? It would just turn the, it would join the paths according to the operating system, something like that. But theoretically, if your location never changes, you could just be like image location is this, right? And then if you moved it, well, even if you moved it, you would still probably have to update this anyways. But this is image location is just a string. String that's in the form of a file path. And then finally, once you have the image location, you want to load it with the Pygames load thing. And this little thing here turns the alpha bits. Like, so if you have transparency in your image, then you make sure it stays, that stuff stays transparent. That's what convert alpha does. Oh, well, actually, I'm pretty sure it also accounts for transparency. Could be wrong, but whatever. Don't worry about it. It's not actually that important then. If you don't include this, it's just whatever. Okay. Finally, what is missing from the sprites? Also, like, you can reference the past slides if you need. So. Oops. Also, Jahan, when they finish answering, can you screen share? Yeah.
Yeah.
Yeah, I'm gonna. Okay, perfect. Good job, everyone. Yes. So if you don't initialize Pygame's built-in sprites class, well, there may be some issues. That's all I'm gonna say. Okay, finally. So we talked about like why do we have this like update method here? Like what's so special about it that makes it different from you just typing like define, updates or some. Well, there's something called sprite groups, which is it's kind of like a list, but there's extra built-in functionality. So this class, yeah, I would probably think of sprite groups as a class as well. You're kind of looking, you're saying in the Pygame, oops, in the Pygame library. Okay, yeah, I would probably think of this sprite thing as a file. So in the Pygame library, locate your sprite file. It's not exactly how it works. It's probably just more of an analogy, but this group thing itself is, I would think of it as creating an object that is an instance of Pygame sprite group class. If you really want to think about it, like that's like the inner working, but it's not super relevant. It is just, it's good to know. And basically what this group object does is you can add things to it, like a list.
Sorry to interrupt. Yeah, you need to share your slide again. Sorry,
No.
share your screen.
Okay. Yeah. So this group here, pygame.sprite.group, I would say think of this as creating an object that represents like a container. And then you can call methods on this object, just like all the other objects. And in this case, it has a few methods. You have add, you have probably remove, or maybe it's kill. It's, oh no, that's not, okay, no. You probably have, I would say you have, you can add sprites with the add method. There's probably other stuff in the documentation. And the other thing that you have with Pygame sprites is you have like a few built-in functions that you can call. So you can call, I believe the syntax is enemy.kill anywhere, and that just removes it from like all groups. It might even delete it, probably does. Something like that. And so I'm pretty sure you can actually iterate over this thing like a list. You can just be like for each enemy in if you wanted, but usually what we actually do is we only really need two functions, and that's your update function and your draw function. So if you call the group has a built-in function, it has .draw and .update as well, and this basically draws all the fairies in the fairy group. So it draws like everything in. So you create a fairy object, you add it to the fairy group, and then you draw all the fairies. And same thing with the update. And usually you put your updates before your draw functions. That's just how it works. It's probably wouldn't make that big of a difference, but good practice. Anyways, so yeah, that's what you call it update. If you like change the name, if you're like capital U for some reason, then this will not work because it'll be like, hey, I'm looking for an update function within the fairy class, and it won't find anything. So make sure it matches. Okay. And finally, that brings us to our end of session exercise. So I'm going to say let's do 30 minutes for this. And if any of you are like behind, if you haven't done the previous exercises or something, like make sure like now's the time, like ask your mentor for help, catch up. And then afterward, I'm thinking we probably have time for both of these, but if anyone's interested, I'll do like a demo with Minecraft agents. So basically, this is oversimplifying it, but I think ChatGPT plays Minecraft. That's the oversimplified version. I'll explain a bit as we go. The other thing I'm thinking is I can do a kind of like, I'm not sure how many of you have used like large language models for coding, but I'm going to try and like demo the, like, it's like like how would I suggest you use it, as well as, am I not screen share? Oh, never mind, that was old. Yeah, and so basically like, okay, here's like where large language models are at with coding. How can you use it? Like, it's actually insane. Anyways, more on that later. So first, yeah, definitely if you, once again, ask lots of questions if you're like struggling with the exercise, or if you have like previous exercise you want to ask about as well, like breakout rooms are the time. So yeah.